Hi, today we are looking at section 4.1, which is counting principles. So this deals with figuring out how many different options there is for things to occur. So we're essentially calculating how many possible scenarios or options there is given a specific situation. So for example, you flip a coin and roll a dice. Use a tree diagram to show how many possible outcomes there is. Okay, so first off, we have essentially two outcomes that we can have from flipping a coin. We can get heads, or we can end up with tails. Now, after we get heads, when we roll the dice, we could get a 1, we could end up with a 2, we could end up with a 3, we could end up with a 4, a 5, or a 6. Tails, same thing. We could have a 1, we could have a 2, we could have a 3, we could have a 4, a 5, or a 6. So how many pathways there is from here to the very end is how many possible outcomes there is. Now to do that, figure out how many possible outcomes, we can just count up both ones here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possibilities. So there is 12 possible outcomes from flipping a coin and rolling a dice. Now, instead of drawing out a tree diagram, we could have also solved this using what is known as the fundamental counting principle. The fundamental counting principle states if there's X ways to perform one task and Y ways to perform another, then there's X times Y of performing both. So for example, with that one we just dealt with, there's 2 possible outcomes from flipping a coin, 6 possible outcomes from rolling the dice. So 2 times 6 would give us that 12 as well. So we'll look at an example. A luggage lock opens with a 3-digit code. Each wheel rotates between 1 and 9. We only know how many combinations are possible and how many combinations would be possible if we can't repeat a digit. So for part A, we've got the digits 1 to 9. So in our first tumbler, we'll have essentially a possibility of 9 digits. Second one, we have a possibility of 9 different digits. Third one, 9 different digits. If we multiply those all together, we find that we have 729 possible combinations. B is a bit more interesting because we can't repeat any of the numbers. So for example, we can't have, say, 2 twice in it. So that means we're actually going to have 9 options for our first digit. But then because we've used one of the digits, that leaves us with 8 remaining. So we'd have 9 times 8. Now we've used 2 digits. So we're down to 7 remaining digits. So we've got 9 times 8 times 7. So we have 504 possible combinations. So if we can repeat digits, we have 729 combinations. If we can't, it drops to 504. Next example, a pizza it offers 2 different crusts, 12 different toppings. How many different free topping pizzas are possible? Before this, essentially our number of possibilities is equal to our crust options times our first topping options times our second topping options times our third toppings options. Okay, so our number of possibilities, we had 2 crust options. So we've got 2 times, and then we've got 12 different toppings to choose from. So we've got our first topping, we've got 12 options. We're assuming we're not repeating toppings. So if we've already chosen one of the toppings, that leaves us with 11 toppings remaining. So our next one for our second topping, we've got 11 things to choose from. Now we've already chosen 2 things, so that's going to leave us 10 to choose from for our third topping. So we have 2 times 12 times 11 times 10. And we find that we can make a total of 2,680 different, or sorry, that should be in 40 different pizzas. That's example. License plates in BC currently follow the following format, where we have a letter followed by another letter, followed by 3 digits, followed by another letter. Now, if the letters I, O, Q, Y, and Z are not used, how many different plates are possible? Now, with license plates, we can have numbers and letters repeat, so we'll keep that in mind. And what's going to be helpful for this is knowing how many letters there is in the alphabet. So there's 26 letters, but we can't use 1, 2, 3, 4, 5 letters. So we know that 26 minus 5 gives us 21 options for our letters. So if we're trying to figure out amount of options, our first one was a letter, so that's going to be 21. Second one was a letter, so that's going to be 21. Now, our digits would go from 0 to 9 because they haven't stayed otherwise. So that's actually going to be 10 digits for each of these. So 10 options for first number, 10 options for second number, 10 options for third number. And then for this last one, we have times 21, which is our number of available letters. And we find that based on this format, we can create 1,728,000 unique license plates.